Okay. All right. Hi, everybody. Nice to meet you. My name is Suhyun, and I'm here to present ML data science tech interview, how to prepare, and what are the resources that are available. So to introduce myself, I am a co-founder of DS Practice. It's the website that helps you prepare for ML coding interview questions. I'll talk about it more later. And previously, I worked at Amazon as a machine learning engineer at Amazon Alexa. And prior to that, I was in Columbia University studying my master's in computer science with ML focus. And I was also mobile engineer making Android applications for Nickelodeon Viacom. Nice to meet you all. So here's a brief survey here. If you can just copy this link. Oops. So I don't think I can copy the link in the presentation form here. So I'll post it at the end of the presentation later. So I'm asking just like a couple of questions about how my presentation went and what kind of audience that I should target for my next presentation. So I would appreciate your participation. So this presentation is for software engineers, data scientists, machine learning engineers, and pretty much anyone who's interested in ML. I'm going to talk about what kind of questions that you should prepare and how to prepare them. So let's get it started. All right. So before we go into the details, I want to talk about the difference between ML research and ML production. So the reason that this is important is because when the way ML is done in research is very different from the way it's done in production. So the kind of questions, interview questions that they ask you, the companies or managers is very different. So for example, when it comes to requirements, in research, state-of-the-art model performance is really important, and you want to make sure that you run the models against benchmark data sets. But in production, they all have different requirements. And oftentimes, a simple model might perform much better because you tend to have a lot of data. And another thing is computational priority. In research, you want to train fast as possible. But in production, the inference speed is much more important because you want to make sure that customers have low latency application experience. And when it comes to data, for research, data tend to be static because you're using open source data. But in production, the data distribution is constantly shifting. So you want to make sure that you monitor the shifts in the data. And fairness, interpretability of the model, these two things are very important when the model is in production because you want to be able to debug how your model performed and if the model decisions were fair or if the model decisions were interpretable so that you can improve your future models. So before we go into different types of ML jobs in ML, I want to go through the typical ML workflow. So in all of these areas, there are different titles, different positions. So sometimes people use ML engineer interchangeably with data scientist. So I want to make sure that what workflow that we're covering in terms of the kind of jobs that I'm talking about. All right, so it starts from data ingestion, data pipeline. So you're getting data from, let's say, web application or cloud data warehouse, any type of data place. And you explore, validate, you wrangle, you clean your data. And then the data is now distributed split into train and test sets. So from there, you're going into model development and you're going into model engineering, different versions of the models. So you want to evaluate your model, how well your model is performing, and model packaging. You want to have different versions of the models. and depends on where the model is running. Maybe you want to have your model run in the browser, edge computing, or just cloud. So different kind of model packaging based on where the model is going to be deployed to. And the regular software code pipeline, because the front end might be a website or mobile application, or maybe something like Alexa. So we have all of these regular software code, as well as machine learning pipeline, meaning model development pipeline and data pipeline, to make sure that we have something like feature stores, or the data is being ingested into the models. And most importantly, we need monitoring and logging tools that could be related to the app performance, so that you can indirectly measure the model performance, or that can directly be implemented on the model, or that the monitoring and logging can be implemented on both pipelines, so that you can have the right feedback loop and you can monitor how the software is performing. So the ML jobs that I'm going to talk about involve every single stage here. It's usually a large amount of data and drift in data, drift meaning like data distribution changes, and continuous model updates are involved. So we're going to talk about this in details, and depending on the companies or where you're working, they might have a different terminology. So machine learning engineers or applied scientists, they usually mean people who are working on the models or the model pipelines. So at Amazon, they're called applied scientists. And sometimes they're called ML platform engineers. They're working directly on creating the platform that I just described. And there's machine learning researchers. They're doing research in ML. So their main focus is having a publication instead of making a product out of ML. And we have data scientists here. So data scientists being, so given the data, they might not make a model, ML model out of it, but they might just do the data analysis on how what kind of model that they should develop. Or sometimes people refer to data scientists as machine learning engineers too. And we have data engineers, so people who are working on the data pipeline that I previously described. And these days, with ChatGPT, we have prompt engineers too. So they're trying to hack ChatGPT, how you can have the results that are consistent. So we have prompt engineers in the ML scene these days. To prepare for ML interviews, so there are 5 different types of questions you can prepare for. We have data structures. It's been the de facto questions that you should always prepare for any software related jobs, and machine learning algorithms, ML system design, sequels, and research. So anything that requires research related questions are usually for PhDs. So for MLE jobs, they might ask you about state-of-the-art research models, but if you have a PhD, they will probably ask you about what your research was about. So I'm not going to talk too much about the research area here because it's geared towards PhDs, and I'm going to focus on the rest of the parts for my presentation. All right, so I'm going to start with data structures. So the reason that I want to start with data structures is because this is something that we're very familiar with as software engineers. And at the same time, this kind of interview structure sets the tone for the rest of the interview types. So I just want to go over some key points about data structures interviews. So these are the topics that you want to be familiar with. Arrays, hashing, and it's in the order of how they're related to each other. So if you know how to solve arrays questions, it's going to help you with 2-pointers questions, and the 2-pointers questions will help you solve binary search, sliding window, linked list, and then it'll help you with tree questions. And trees are going to be useful in backtracking because every backtracking question can be turned into tree actually. And backtracking is going to help you with graphs questions, and backtracking can help you with dynamic programming, because dynamic programming, you can start with backtracking and you can add memoization to make it more efficient and optimized. So, and from trees, you can obviously do tries, because tries are extended version of trees, and you can do heap and priority queues that use trees. So I like to go over these, this structure so that you can, so these are the main topics of data structures. So when you, during the interview, this is personally what I do for data structures question. I spend about 10 minutes in coming up with edge cases and brainstorming solutions. And then the next 10 minutes, I focus on writing code. Then the last 10 minutes, I work on test case. So I want to just go over the details of all those 3 steps here. So number 1, this question is valid for every single interview question type, that you want to start asking questions instead of going straight into coding or going into writing a diagram for system design questions. So you want to ask questions and then come up with edge cases. And usually edge cases involve input being null, size, input size is 1, or multiple size input, then it's duplicates, negative numbers, or 0. And when it comes to sorting the numbers, you want to always consider increasing sequence and decreasing sequence and zigzag sequence. By that, I meant increasing and decreasing that sequence. And you want to provide obvious solution first. So you want to suggest something like library functions. Oh, why don't we use like sort function that Java library provides? Something like that. And then you want to try to turn the problem into a different one by changing the data structure to represent the given input. That's going to help you solve a problem and look at the problem in a different way. And I like to do a small example set and see if there is a pattern to figure out what kind of data structures or what kind of algorithms that I can apply. And through that, you want to come up with at least 2 solutions. It's good to come up with as many solutions as possible and discuss the time complexity and space complexity. Then you can choose the most efficient one and implement them. So from step 1 to 5, I like to spend about 10 minutes and then discuss with the interviewer about what solution that I should implement. Then the next 10 minutes, you want to write inputs and outputs of a function, point out what specific values you want to return from a function. And then you start with something like input checks. What if I get a null value? What's the base case? And then you want to continue writing code. Then after you're done with writing code, you want to go through a simple example. So this step is actually very important because ideally you want to catch your own mistake during this step. And it's okay if you have made a mistake earlier in your code, but if you catch your own mistake, it's actually a huge plus. So I highly recommend that you go through a simple example. Ideally, all of those edge cases that you came up with in step 1, make sure that they're like small enough so that you can go through with your hand first. So as you can see from this, what I wrote so far, the main thing is communication. So I just spent 10 minutes on coding, but the rest of 20 minutes were communication. The first 10 minutes were about writing algorithms, what kind of data structures I should use. So it's about communicating what I know and getting inputs from the interviewer. And the last 10 minutes were going through test cases to make sure that if my algorithm was correct. So the interview, you're going to see from the rest of the slides that communication matters more rather than solving a problem or coming up with quote unquote ideal solution. So the next type of question that we want to focus on is ML coding questions. So this is what makes ML interviews special, because for software engineers, we don't really have to prepare for this type of questions. So an example is implement k nearest neighbors for binary classification. When you're given such a question, you want to apply with a similar strategy that I described before for software engineering interviews. Number one, you want to ask clarifying questions. What are edge cases? What kind of data are we talking about? Are we talking about images, text? Are we talking about just regular scalar values? So I actually wrote down a code here for what KNN looks like. It might be familiar to a lot of you. So this is a really good chance of this interview that you want to talk about your knowledge on different distance functions. So there's Euclidean distance, cosine similarity, Manhattan distance. You want to mention all of them so that to let them know that you are knowledgeable in implementing KNN. And also you want to hear from them about what kind of business problem that they're talking about with KNN and what kind of distance function would be useful for the interview purposes. The second example is implement and fit a linear regression model. So it's similar to the previous one. And for all of these questions, I highly recommend that you ask detailed questions about their business objectives, because depends on what kind of business problem you're trying to solve, the inputs and data engineering that's required for each regression model, it would be completely different. And you want to mention that you know the importance of the background knowledge and when it comes to doing ML modeling. And the third type of example question is loading data from a CSV file, clean and transform it and save it into a new CSV. So it's like data engineering question or feature engineering. So they might ask you about augmentationing the features, and they might ask you about dimension reductions. And the last one is fit a linear regression model to data that is 20 times larger than your RAM. And then what are you going to do it? So you can talk about some numerical ways of approaching it, or you can talk about some software engineering ways of approaching it. So these are the type of questions that you can actually see from dspractice.com, which is a website that I had made. And I also host Meetup. It's bi-weekly at this point. So for ML Tech interview prep, you can attend my meetups too. I also recommend this website, this course from Coursera, Apply Machine Learning in Python. I think the course is very practical and it goes over all the details within the context of what people use frequently. All right, so next one is ML system design. So this is another type of interview that's quite different from regular software engineering interview. So I wrote down the example questions here in rubric. So an example question would be implement online and offline training pipeline. So when you're given a question like that, and I've actually given a question like that, it's actually better to ask them about, when it comes to clarifying question, what exactly are we trying to build? Because it's pretty vague. What are we trying to train? Like, what's the input and output of the model? So the better question for that is implement an end-to-end ML pipeline to recommend products to purchase for Amazon.com. So rubric for such questions is Have you described the problem exactly with inputs and outputs? And have you figured out the throughput and latency for the system? Have you described design with enough clarity and detail so the interviewer knows what you're going to build? And have you provided reasonable metrics so people know exactly what you want to measure? Have you described continuous model updates with details? So this is actually an important part here, continuous model updates. So that makes MLOps, the word comes from DevOps. So machine learning operations, the platform makes it different from regular software engineering DevOps, because regular software engineering DevOps, you don't necessarily update the code as often as the model updates happen. And most importantly, it's the model size is sometimes people have like gigabytes or maybe terabytes size of model. And then that also includes the data. The data is going to be much bigger, the data size, and it's usually multiple models. So how are you going to update? How often are you going to update them? So, and how are you going to detect data drifts through monitoring, and what kind of things are you going to look at to make sure that it's time for retraining the models, and or maybe should we just do model quantization to make sure that model is the model size is reduced for a different kind of deployment. So that's one special thing about ML system design that you want to mention. And have you described fault tolerance of the system? Have you described what are pros and cons of your current system is? So this is actually the rubric that I use for our meetup. And please let me know if you have any feedback about the rubric, that you want to add more stuff, or you have any suggestions. I'm happy to improve the rubric here. So the first thing when it comes to ML system design is you want to calculate latency, throughput, just like any other system design questions. You want to calculate your metrics. So in the ML setting, there's a lot of batch. Sometimes people use batch queries, because when you just use a single query, latency is 10 milliseconds and throughput's 100 queries per second. And when the latency increases, throughput actually decreases. But in batched queries, when you're batching everything, as the latency increases, throughput increases too. And that's because if the data is available in data warehouse and you batch them together using a tool like MapReduce or Spark, then you can actually make the transaction much faster. I mean, you can increase the throughput like that. So the way MapReduce works is the system splits up the data across different machines, and each machine starts running the user provided map program. And the map program takes some data and emits a key value pair that the system shuffles around, reorganizes the data so that all key value pair associated with a given key go to the same machine. So every data with the same key goes to the same machine to be processed by Reduce. And then Reduce kicks in, then Reduce processes the data in the same machine, emitting a new key and value. So Reduce is doing the work. So the result of this might be fed back into the Reduce program for more reducing, but usually it ends from map to Reduce process like that. So you're taking advantage of distributed systems, a lot of clusters that you have. So all the work, instead of having one pipeline that's doing a single query, you're managing a lot of data processing at the same time. So to give you the components, how they are put together, here, this is the application. And the way the batch prediction works is that because batching, the latency is pretty high. And these days, you want to make sure that everything stays within milliseconds for the UX. So prediction is usually made in advance like that. And so prediction is made in number one from batch features, and batch features are coming from data warehouse. So a repository for storing structured data is called a data warehouse. And a repository for storing unstructured data is called data lake. And data lakes are usually used to store raw data before processing. And data warehouses are used to store data that has been processed into formats ready to be used. And then the prediction results are also stored back into the data warehouse. And the app is going to query, get the results from there, prediction results. So the model can use the historical data. But the problem with this is that it's really hard to continuously update. For example, when Netflix has recommendation engines and you've been feeling pretty down, so you've been watching a lot of horror movies, but one day you feel better and you want to start watching comedy, but after watching one comedy movie, you want to watch another comedy movie, but because of the batch prediction, Netflix didn't update your prediction immediately, then that would be a problem. That would be inconvenient, or it's not the ideal solution for that. And that's why we have online prediction here. So we have all the components that we had for offline prediction, the prediction pipeline, as well as monitoring dashboards, data warehouses, and the way you process historical data and model stores. And this time you added Kafka or Kinesis. So this is the streaming engine so that the real-time data can be streamed into data warehouse. So actually, there's a difference between real-time and online. So online and streaming. So online is something like real-time or near real-time prediction that people want to make, something that you made a click, and then based on that click, you want to be recommended a product immediately based on that. But streaming prediction is usually based on streaming like videos, or maybe based on your NLPs, like speaking, some sort of like translation streaming. So this is the Facebook Meta's AI optimization platform. And I wanted to show you here, this is from their blog post. It's about what their current system. So Looper API is pretty much their real-time. It's like their API so that you can get data real-time and do all the data wrangling. So they have feature store. So you can think of feature store as data warehouse for the models. So the models can get the data pretty fast. And also you can monitor the feature store to see if there's if the mean or any metrics changed. And they have the predictor system and real-time joiner. And they have monitoring system. And they have model training system as well as model canary. Their strategy blueprint combines configurations for features, labels, models, and other stuff together and put it back into the Looper API. And what I wanted to show you was model canary here. So in order to do continuous updates in the models, there are multiple strategies. Number one is shadowing. All these principles are actually traditional software engineering principles, but they apply to model development as well. So shadowing development, deployment is deploy the candidate model in parallel with the existing model. And for each incoming request, it goes to both models to make predictions. But only one serve the existing model's prediction to the user. So it's like you have two models that are deployed, and then you want to make sure that the new model has the similar predictions or pretty much the same predictions to make sure that the new model doesn't perform badly compared to the previous one. And then when you think the model is ready, then you can start deploying the new model. And we have the A/B testing of the model and interleaving experiments. So so here's the diagram here. A/B testing is something that we're already familiar with. So we have two models, and we want to show different models to different people to see which one is getting more traction, or which one makes more clicks from the people based on its recommendations. And interleaving is give them results mixed from multiple models to make sure to see like which model competes best compared to other ones. And we have canary release. Canary release is like it slowly rolls out the change to a small subset of users before rolling it out to the entire infrastructure and making it available to everybody. So these are the things that you can do so that you can do the continuous updates of the models and make sure that the model performance doesn't go down compared to the previous one. So in order to prepare for ML system design, try to make your own ML productionized app using AWS, GCP, Azure, Hugging Face, Relevance AI. There's a lot of cloud systems you can take advantage of these days. You can also take a look into Snowflake as well, and you can learn from other people's examples, and you can take a look at what other companies are doing. They would usually have a company blog post about it, their engineering blog post, and I actually made blog post about machine learning serverless. So you can check it out too. All right, so the last type of questions that I'm gonna go over is SQL questions. And SQL questions are not necessarily asked for MLE jobs. It's usually geared towards data analysts or data scientists. So if your job's going to involve using database a lot, then they're going to ask you SQL questions. So an example of SQL question is combine two SQL tables like below, and you can use left join to do that. In order for you to practice more SQL questions, you can go to leetcode.com or stratascratch.com. They have a lot of SQL questions from multiple companies for you to practice. All right, so this is the overview of all different types of questions that I just went over and where you can get resources to prepare for those questions. So I'm just going to go over some frequently asked questions based on my previous presentation. So as a software engineer, how do I make a career transition into ML? So I'm asked this question pretty often, and actually I personally myself did the same. I was a mobile engineer, and I made a career transition into ML. So there's no one size fits all solution. Common things that I've seen people do are, number one, take on ML projects within the same company. You can ask them for something related to ML, or you can move to a different company, somewhere that is going to be more lenient or flexible about you taking on different types of projects as you like to, or maybe with a different title. The third option is you can consider graduate school. So I personally went back to school, and then I I made the transition, but that's not necessary. It's actually, you can continue to add more ML experience on your resume through online certificates or open source contribution side projects. You can go on Kaggle, and that can be added to your resume. So with that, you can get an ML related role, or you can start taking on more ML projects. So as a non-programmer, how do I make a career transition into ML? It depends on what kind of ML job you're looking for. MLE jobs require knowledge of programming and software engineering. So I recommend that you learn both ML and software engineering on the side. And you can start with a fun side project of your interest. And these days, you can do prompt engineering. So you can have access to ChatGPT API and try to figure out how you can have the consistent results, how you can generalize the prompt. So that's one way that you can start doing ML related work. And as a software engineer, how can I start learning about ML? And being a software engineer is a great place to start, actually. You can start learning about ML through online courses like the Coursera. And if you want to focus more on software engineering side of ML, I recommend that you dive into distributed systems. So this course will actually go over MapReduce, something that I described before, like in depth, and you'll read research papers based on that. And you'll also learn about all the distributed systems topics with research papers. So it's very in-depth, a really well organized course, and everything is free. The lecture notes, homework, everything is available online. So can I get an MLE job without a PhD degree? Of course. Some companies require a PhD degree strictly, and they also require publications. But there's plenty of companies that don't require a PhD degree, and experience counts more than your academic history. So one thing that I like to recommend is online master's degree from Georgia Tech through Udacity. So this course, when you go through it, they will give you a certificate. I'm sorry, they will give you a master's degree, but it doesn't say that you got it through an online program. It's same as a regular master's program, master's degree from Georgia Tech. And it's much cheaper because you don't have to be on campus. The only downside is that it's not available for international students, so just keep in mind. Yeah, that's it. So just more practice, and you'll be able to maybe one day get a job that you really wanted to get. So before I finish, I'd like to remind you that here's the survey form. I'll actually copy and paste here. So I just want to hear about how the presentation went, and how, if you have any feedback, I'd like to hear from you. And also I want to hear about your journey, your interview journey, like how it's going, and if you have any like things that you want to unblock your career related journey. I want to hear about it. And yes, thank you everyone for being here, and let me know if you have any questions.